The question of our trigonometric function problem of SAT level math 2 will be find the lengths of the longer diagonal side of a parallelogram if the sides are 6 inches and 8 inches and the smaller angle in the parallelogram is 60 degrees. And there are some choices. There are totally 5 choices we can choose as our answers right over here from A to D. And obviously we can see that this is a question about solving the diagonal side, longer diagonal side of a parallelogram. So in order to approach this question, we need 3 things to know. And the first thing to know is the origin of trig values, which is sines, cosines, as well as tangent. We've talked about the origin where the sines and cosine tangent, the trigonometric function values, was obviously going to be a triangle, but not just a triangle, it is a right triangle. This is the first thing we need to know in order to approach this question. So there should always be a right angle in order to approach or apply our trigonometric function. And any time when you apply our trigonometric function to a triangle, we always need an angle given. So let's say the angle is given right over here. This is just an example. Let's call this angle or label this as x degrees. And the only reason why we input this as x degrees because we know that x is a variable, which means it changes depends on times. And we don't know an exact value of this angle. So from this x degrees, let's think about every single thing that we can talk about from the right triangle. And if you don't know what the right triangle is, that means it is a triangle with a right angle. And the right angle is a 90 degrees that shows with this little square box right over here. And if you talk about everything about right triangle, the first thing will be, let's label every single side in order to approach our trigonometric function. And the main element that will define our trigonometric function will be this x degrees. And from this x degrees, we are defining our trig values, sine, cosines, as well as the tangent values. So firstly, if you label this side, what is this side as we look at the perspective from our x degrees? Well, this side is the opposite side of our x degrees. So this will be a opposite side. This side right over here will be the opposite side of our main element, main angle, which is our x degrees. And now let's think about what is this side right over here. This is clearly not an opposite. This will be an adjacent side. This will be an adjacent side. But a lot of people might confused with in this way. This one right over here is also an adjacent side. How should we call it if we call this length adjacent side? And obviously, as we can see in lots of videos, this side is obviously bigger or larger than this adjacent side. And from the definition of our right triangle, the most important or the most famous theorem in our right triangle is a Pythagorean theorem. So we're going to apply our Pythagorean theorem as we go to approach this question. And the main element that we're going to use in this triangle is that this length is not an adjacent side. It is an adjacent side, but we're going to label it as the hypotenuse. We'll label this length, we'll call this as the hypotenuse of our right triangle. And what is the definition of our hypotenuse? The hypotenuse means it is a longest side. It should always be the longest side in our right triangle. And how can we solve or think about the hypotenuse? Well, the longest side should always be opposite side with our right angle. That is what the hypotenuse, our longest side in our right triangle, will going to be. So we said it every single things or elements that we need to require in order to apply our trig values. So right now, all we have to do is apply our trigonometric function values, sines, cosine, as well as tangent. And before we apply our trig values, the most important thing when it comes to applying this is the angle. If the angle is not given, we can't apply our trigonometric function. And in this case, we will label our angle as the x degrees right over here. And our x degrees will be our main element that will define our trigonometric function. And as we can see, there are three different types of trig values: sines, cosines, as well as tangent. So firstly, the first thing that we're going to talk about is what is the sine? What is the sine of x degrees? What is the definition of our sine x degrees? Well, the definition of our sine x degree is sine of this main element angle. It will be an opposite side over a hypotenuse. The sine axis definition is opposite side over a hypotenuse. This is what the sine's definition is. So this will be our sine x, the first thing that we're going to talk about. And let's think about the second thing. What will the cosine of x will going to be? Well, the cosine of x is a little bit different with our sine. It is a adjacent side over a hypotenuse. So it will be adjacent side over our hypotenuse. And what is our hypotenuse again? It is a longest side in our right triangle. So lastly, let's think about what is our tangent of our x degrees. Well, our tangent is a little bit weird compared to our sine or cosine. It will be sine of x degrees divided by or over cosine of x. So the difference between tangent and the sine and the cosine is, we know the sine and the cosine's similarity. There is a similarity because they are all containing our hypotenuse, which means, what is the hypotenuse? It is the longest side in our right triangle, and it should always be a opposite side of a right angle, and they all contain our hypotenuse in their equation. But the different thing in our tangent of x is it concludes both sine and our cosine values. This is the main difference between sine, cosine, as well as the tangent values. So these three things that we talked about right now is the main thing that is useful, which we call it as the trigonometric function values. So sine, cosine, and tangent values. Sine, cosine, and tangent values will be our trigonometric functions values. So we're going to be trigonometric functions. And the only reason why we called it as the trigonometric function values is because the main point of this will be defined by the word trigonometric, and the trigonometric is a short form or another way to call a triangle. So we can see that it is a function that we can only apply to our triangle, especially to our right triangle. This is what the trigonometric functions values will look like, and there we usually learn it as sine of x, and then cosine of x, as well as the tangent of x. We only learn these three things in our trigonometric functions, but as we go through our graphs of our trigonometric functions, we'll be able to apply three more trigonometric function values. So this was the first thing that we had to know, which means the origin where the sine, cosine, as well as the tangent was originated from. And it was originated from our triangle, especially a right triangle. So this was the first thing that we need to know in order to solve our equation. And the second thing we need to know in order to solve our equation is formula of law of sines and law of cosines. What is the law of sines as well as the law of cosines? So firstly, we're going to talk about what is the law of the sines, and as we can see, it will be one of the complicated form of our sine values, which means it is related to our trigonometric function values, that we talked about in the upside. So what we're going to do is, before we think about its formula, we're going to talk about when do we use and what does this law of sines means. So the law of sines' whole point is that it shows that the sines of the angles, sines of these angles of a triangle. And what is the main angle in our right triangle again? It will be our x degrees right over here. And the sines, this law of sines shows that the sines of angles of a triangle and the lengths, what is the length? Is the same thing with width, which means it shows how long the size is in our triangle. The lengths of the opposite sides. The opposite sides are proportional. And what does proportion means? They have exactly same proportions. So the law of sine shows that the angles, the main words in this case will be the sines of angles of a triangle and the lengths of the opposite sides are proportional. This is what the law of sines means. And right now all you have to do is think about what the formula is. So for the formula of our law of sines, this will going to be sine of a, because it should always contain a sine of a degrees over our small a is equal to sine of our b degrees over our small b, and that should be equal to sine of c degrees over our c. This is what the law of sines will be, which is one of the most useful, or we can say the hardest part in our geometric function. It is the law of our sines. So the formula is sine of a degrees over a is equal to sine over b degrees over b is equal to sine over c degrees is c. And if you related this to our law of sines, this equivalent sign shows that they are proportional. And what are they proportional? When we might confuse why there are a small a and a big A, small b and the capital B, as well as the small c and the capital C. So we define this in this way. So what we define is the capitals one, the one that is formed by the capitals letters, will be the main angle which is the main element that defines our geometric function values. And for the small ones, small letters of our alphabet, will be our side, which is one of the main supporting things that support our angle to define our geometric function values. So for a whole of this, we'll be saying that this will be our main element of law of sines. And what is our law of sines again? It is a theory that we use. We use the sines to say that the angles of a triangle and the lengths of opposite sides are proportional. And from the law of sines, we need to think about two things. The first thing is the angle, and the second thing is a side. And more importantly, we can say that this over this should always be a proportional. So this is what the law of sines in our geometric function will going to be. So this was the first one, and let's think about the second one, which is the law of cosine. And before we think about the law of cosines, as we can see from our law of sines, it should be a complicated formula of our cosines, which means this is related to our trigonometric function values. In this time, we're going to talk about what is the law of cosine in our trigonometric function will going to be. And as we talked about, this is a complicated formula that is an advanced one for our cosine values. And if we remind ourselves what the cosine was, it was adjacent side over hypotenuse. And before you think about it, if you apply every single formula or the things in our trigonometric functions, they always should give us the angle. The angle is the most important thing that defines our trigonometric function, which means no angle means no trigonometric function. So this is a law. This is what the law of cosines were going to be, and the law of cosine is a general form of the Pythagorean theorem. And what is the Pythagorean theorem? It is a theorem that was proved by a Pythagorean, and for the formula for a Pythagorean theorem, so we'll write Pythagorean's theorem. The formula for a Pythagorean theorem will look something like this: a squared plus b squared is equal to c squared. And we must see three variables, and the three variables will be our a value, b value, and c value. And according to Pythagorean theorem, a squared plus b squared is equal to c squared. And what is a plus b and c? So if we bring our triangle right over here and draw the same kind under the Pythagorean theorem. So this is a triangle right over here, but the only thing that we can apply our trigonometric function is only when this little square form is given, which means it shows a right triangle. So let's apply every single thing right over here that we applied this setup in order to apply our trigonometric function values. What was this value? If you see that the main angle is right over here, which we call it the x degrees, this one right over here, it will be a hypotenuse. So we can write it in a different color to show the difference. This will be a hypotenuse. And what is the definition of a hypotenuse again? It is a longest side. This will be a longest side in our trigonometric function triangle. And the way to solve it, the way to define it will be should always be opposite side of our right angle. What is the right angle? It's the angle that shows that it is a straight right triangle. So what is this side right over here? This will be an adjacent side of our x degrees. So this will be an adjacent side. So before we apply our trigonometric function, we always need to set up the basic drawing for this. And what is this picture right over here? Well, this will be an opposite side of our x degrees, our main angle. So this will be our opposite side. This is what the x degrees will going to be. And from here, we can apply what this Pythagorean theorem means. A squared plus b squared is equal to c squared. Where a, b are equal to the legs. And from here, we're not mentioning the legs that we have. We're mentioning about the legs. What are the legs? They show that it is a size except for the hypotenuse. And again, what is the hypotenuse? The hypotenuse means it is a longest side. So this will be a hypotenuse will be a longest side in our trigonometric function problems or any kind of things. So this is what the legs means. They're the size except for hypotenuse. And where is the hypotenuse? We define hypotenuse with this c. So the c value will be our hypotenuse, the longest side in our trigonometric function. And with this two main things, we'll be able to apply or prove our hypotenuse in Pythagorean theorem. We'll be able to explain what the Pythagorean theorem is through this pattern. And the Pythagorean theorem means the two legs, which is a squared plus b squared, the addition of the two square forms of our legs, so a squared plus b squared what is the a squared plus b squared? They are the addition. They are the addition between our two legs. And then that one should always be equal to our c squared. And what is the c squared? C squared will be our hypotenuse. And the hypotenuse will be the longest side in our geometric function. So this is what the Pythagorean theorem was. And with this pattern, we will be able to solve what the able to understand what the cosines, law of cosines, will going to be, because it is a general form. This is a general form, a Pythagorean theorem. So this is a general form about a Pythagorean theorem form. And what will going to be? This will be a law of cosines. So let's think about what is the formula for our law of cosines in order to apply this to our real life questions that we're trying to solve. Well, the formula for a law of cosines obviously thing that contains a cosine. So the value of our law of cosines will be, the first thing will be a squared is equal to b squared plus c squared minus 2bc times cosine of our a value. This is what the first of our first law of cosine will going to be. And let's think about the second one. When we are trying to solve for a b squared, b, that is equal to a squared plus c squared minus 2ac times cosine of our b value. And if you're trying to solve for our c value, what should we do? C squared is equal to a squared plus b squared minus 2ab times cosine of our c value. And obviously these are exactly same things what you're trying to solve. These are exactly same things. And we call this as the law of cosine. We call this as our law of our cosines because it is a thing that contains our cosines value in it. So the reason why we say that is a general form of a Pythagorean theorem is because we know the Pythagorean theorem is c squared is equal to a squared plus b squared. And if you compare this Pythagorean theorem form with our law of cosine form, right over here, they are exactly similar. So that's why we call our Pythagorean theorem as the general form of our law of cosines. So this is what the law of cosines formula will going to be. And a lot of people will be confused again. What is the difference between a big capital letter and a smaller letter? And as we can see, our capital letter will be our angle. It shows our angle. And for our, not a capital, and for our smaller alphabet, it shows, so our smaller alphabet shows it is a specific side. So smaller angle, smaller will show that it is a side. With these two things, we can apply our cosines, law of cosines to our original problem. So we thought about two main things. What is the law of cosines and the law of sines? And now let's go back to our original question to see what the original question was. And our original question was solve for the diagonal side of our parallelogram, which means we need to draw what the heck is parallelogram. And well, the parallelograms, the definition of the parallelogram is it has the two parallel sides. It is similar with the rectangle except the rectangle contains a 90 degrees. So let's simply draw an approximation of our parallelogram. Say the parallelogram that we're trying to solve, it looks something like this, which means this side should always be parallel to this side, and this side should always be parallel and exactly equivalent with this side either. So this is a parallelogram that we are seeking for, and all we have to do is apply and label every single length. And obviously we know that this angle right over here should always be equivalent with this angle, according to a parallelogram's definition. And this angle right over here that I'm pointing out should always be equivalent to this angle right over here. So what I'm going to try to do is right now is label every single thing that we're given. They said one of them is 6 inches and another one is 8 inches. So let's simply get this as the 6 inches because it obviously looks smaller than the another one. And obviously, or clearly, this will be in 8 inches. So after it became the 8 inches, and this will be our 6 inches, there is one missing one. Where is the angle? Because the angle is the most important point in our trigonometric function. Well, they gave us in the question, it says the angle is 60 degrees, but a smaller angle. So we will just simply set this angle as 60 degrees. Let's just say this angle is 60 degrees. And that means this should also be a 60 degrees. But right now, we also need to try to solve the other angles. According to a formula for it, we know that the total angles for our parallelogram will be a 360 degrees, the addition of the 4 angles, which means this should be equal to 2 times our 60 degrees one, and then plus our 2 times our missing one, which we can just notate as the A. So this one right over here that are missing, we can simply notate as the A value. So 360 degrees is equal to 2 times 60 degrees plus 2 times A. What is 2 times 60 degrees? Well, it will be 120 degrees plus 2A should also be 360 degrees. Well, if we that is equal to our 360 degrees. All we have to do in order to isolate our A value is subtract 120 to the both sides. So if we subtract all of them from the both sides in order to isolate our A value, we're going to get 360 degrees minus 120 degrees will be 240 degrees, and that should be equal to 2A. In order to solve for our A, all you have to do is divide whole terms by 2, and we will simply get A value is equal to 120 degrees. And our A value is our 120 degrees, which means the angle, another angle except for the 60 degrees will be 120 degrees. So our A value will be our 120 degrees, and here also 120 degrees. So these are the all set up in order to apply our trigonometric function. And what is the thing that we are trying to solve? We're trying to solve the diagonal line. What is the diagonal line? There are 2 types of diagonal line. It can be either this diagonal line from the vertices to vertices or this diagonal line. And we can obviously see that this one right over here that I'm pointing out is the larger one. So we're trying to solve this one. But people might ask that how could the trigonometric function related to this? We might think about parallelogram as 2 types of a triangle. So we are trying to solve for this one. What should we do? What should we apply? Well, law of sines is basically to solve for our angles of our trigonometric function. In this case, we're trying to solve for our side that we're gonna notate it as the A value. So we're trying to apply other thing, which we're going to be our law of sines. Because the law of sine is one of the general form of our Pythagorean theorem. What is the Pythagorean theorem? Try to solve the lengths, which means the side of our trigonometric function problem. So what should we do? So what we need to do is apply our law of cosine. Let's remind ourselves what the law of cosine was. Well, the law of cosines will be, all you have to do is use one of our cosines. You'll be a squared is equal to b squared plus c squared minus 2 times bc times cosine of our a value. So right now, let's think about what this each variable is. Well, as we can see, a, b, and c are they're all going to be our size, and our cosine of this big letter, capital letter, will be our angle, which is the most important thing in our trigonometric function. So right now, all you have to do is, what is the a they're trying to solve? Well, it is the a. We don't know it yet, so we simply do this as the a squared. What is the b one? Well, b is the given one. It can be either 6 or 8, so we'll just simply plug it as 6. We have squared plus c squared. What is other c? Well, it should be the 8-inch that is parallel right over here. So c value will be our a squared. But the addition, when it comes to solving the addition or the multiplication, the order won't be a big matter. So this one, minus 2 times what is our b value? Well, b value is 6. Times what is our c value? Where our c value is 8. And then times cosine of our a value. What is the angle that is given? Well, it should be 120 degrees. Calculations will be a squared. The isolated term is equal to 6 squared, which is 36, plus a squared, which is 48. And then all of that minus 2 times 6 times 8 is 48, times 2 will be 96, times cosine of our 120 degrees. So we can even simplify it furthermore. 36 plus 48 will be 4, and the 84 minus 96 times cosine of our 120 degrees. So all you have to do is solve for this through our calculator and then apply it to our a squared term. So let's put our calculator out, and for our calculator, all you have to do is input our a squared is equal to 84 minus 96 times cosine of 120 degrees. First, let's think about what is cosine of 120 degrees. So all you have to do is input our cosine, and it will be second in the cosine. So let's turn this on. So, and then it will be second and the cosine. So let's clear this. So second button plus cosine of 120 degrees. So 120 degrees, what will it going to be? This will be negative 1 over 2. So cosine of 120 degrees will be negative 1 over 2. So our final calculation will be negative 1 over 2 times negative 96, and then plus 84, and that should be equal to a squared. So let's think about it in this way. We know that this will be 84 plus negative 12 times negative 96. Well, it is the same thing with 1 over 2 times 96, which will be equal to 48. And then 48 plus 84, what will it going to be equal to? That will be a squared. And what is 48 plus 84? Well, 48 plus 84 will be 2, it will be 2 plus 132. So our a squared will be 132, which means our a value, we need to isolate it by taking a square, taking a square root form of 132. So let's put our calculator again, and our a value is square root 132. So let's do, where is the square root? Is right over here. We need to put this second button plus 132, and we need to trying to solve for the approximation, which will be 11.4891. So it will be approximately 12 in this case. So what the answer will going to be? The answer in this case will be our b value. Our answer to this question will be our b value, which will going to be 12.